hole. But don't worry about moving to Mars just yet. The black holes Maria and her colleagues expect to create are tiny. So tiny that they will evaporate in a fraction of a second.
The microscopic black holes, as soon as they are produced, they immediately decay with a very, very short lifespan. There is a spray of these particles, and that is the clue that such an object might have been created.
The LHC has been looking for these black holes for over a year. So far, they found no hint of even a single black hole being created. Extra dimensions remain elusive. But Lisa Randall thinks that might be because they're different from what most scientists expect. She believes extra dimensions are warped and that they are passageways to a parallel universe. Extra dimensions are not easy to see. If they were, we'd have found them long ago. Many scientists now believe we'll never have the technology. But extra dimensions might still reveal themselves, because they might be separating us from a parallel universe. An entire cosmos could be lurking less than a trillionth of an inch away. Harvard professor Lisa Randall has a radical new idea about extra dimensions, one that will change the way we see our entire universe. She began with string theory, the idea that all the fundamental particles are just vibrations of tiny, nine-dimensional strings. Then she added in Joe Polchinski's ideas that strings making up all the stuff in our universe had to be stuck to a giant three-dimensional object called a brain.
There are two types of strings, strings with ends and strings that are closed loops, like rubber bands. And the strings with ends, those ends, have to be somewhere. They can't just be anywhere in higher dimensional space. They have to be on the surface of a brain. And if that's true, the particles associated with that string will also be on the brain. And it turns out that all the matter we know about, and also the forces through which they interact, might all be stuck in a brain through this mechanism, except for gravity. Because gravity is never associated with open string. Gravity is associated with the closed string. And closed strings have no ends. There's no mechanism that makes it stick to a brain. A closed string can be anywhere.
Lisa's math suggested that gravity might be so weak because the closed-loop strings that carry this force, gravitons, are being pulled away from our brain and concentrated instead in a parallel universe that's separated from us by a fourth dimension.
You can imagine that these two buildings behind me represent two different brains. And we maybe are living only in that building or that brain. If gravity is concentrated at the other building, we might only get a tail end of gravity. It might be that that could explain why gravity is so weak for us.
Gravitons flow freely between our brain and the one that's across the fourth dimension. But the gravity in that parallel world is so strong it compresses space trillions upon trillions of times smaller than ours. The space between these two brain worlds is warped. As gravitons move from the dense gravity brain to our brain, they spread out and their force gets far weaker.
There you go. You could put yourself there.
Things get rescaled as you go from one place in an extra dimension to the other. So whereas things might be extremely heavy here, they could be exponentially lighter here, which would naturally explain why gravity is so weak.
Lisa Randall's idea of a warped fourth dimension separating us from a parallel universe where gravity is just as strong as the other forces of nature has set the world of physics alight. Back at the Large Hadron Collider in Geneva, the beams will soon be smashing together with enough force to produce particles that could prove this warped dimension really exists.
Well, if this idea is right, you would actually be able to make particles that essentially have momentum in another dimension. Now, we don't see that other dimension. What we see is the effect as if the particle had mass, and the mass turns out to be the right mass that it can be produced at the energies of the Large Hadron Collider, we hope.
Any day now, news may come from the Swiss Alps that the world is fundamentally different from the way we've always imagined it. But there is one more twist to this epic hunt for warped or curled up extra dimensions. One scientist thinks our search is doomed to failure. She does not believe there are more than 3 dimensions. She thinks there is only one. How do you build a universe? Do you need 3 dimensions? Or do you need 4, 9, or more? These are the most fundamental questions scientists can ask about our reality. But the simplest questions are often the hardest to answer. Swarms of scientists at the Large Hadron Collider and labs around the world are hunting for evidence of extra dimensions, be they warped or curled up in tiny loops. They hope to make a major breakthrough within the next few years. But Renato Lal, a physicist at the University of Utrecht, isn't holding her breath.
Of course, one of the problems you have in string theory is that there's all these many dimensions. Then you have to explain why you only see a few of them. So that would be wonderful if you could do that. But currently, that's too difficult, or no one has managed to show that.
Renata believes that the extra dimensions predicted by string theory are merely a mathematical quirk, and the theory itself is likely to be wrong.
Of course, it raises the question of, well, can we maybe do without these extra dimensions whatsoever?
Renata Lal's dislike for the extra dimensions of string theory is matched only by her passion to attack the same puzzle it was created to solve, the mystery of gravity.